Good evening, girls. Till now, we have done with Unit 1 and Unit 2 of Digital Communication, and now we will enter into Unit 3 of Digital Communication. Unit 3 is all about errors, its correction, its detection, and different codes used to correct the errors which are received in the process of communicating. Now, communication may be either in between two networks, between two persons, or between two systems, or between two points. So, communication system between two computers will be like this. You can see computer 1, computer 2. One can be receiver, one can be transmitter, and computer can only understand binary signal. Therefore, the communication is digital in case of computers, and it is represented by a binary signal. And the second signal is added noise, which is a disturbance or unwanted signal. Similarly, if the communication is between two networks, it will be like this: network 1 and network 2. In this case, signal may be either of analog or of digital. If it is an analog form, it is simply a voice signal. If it is a digital form, it is a binary signal. Here also you can see a noise. Now, in information theory and coding theory, with applications in computer science and telecommunication, error detection and correction or error control are the techniques that enable reliable delivery, smooth delivery, delivery without any noise of digital data over unreliable communication channels, అంటే over many channels at the same time. Many communication channels are subject to channel noise, and thus errors may be introduced during transmission from source to receiver. What is telling? Many communication channels, what will be added? Noise will be added along with the data when we are trying to send a data from transmitter side to receiver side. Such kind of noise is simply called as error. Okay, now we have to detect the error, and we have to find an alternative to correct that particular error. So, error detection techniques allow detecting such errors, while error collection, sorry, I'll repeat once again. Error detection techniques allow detecting such errors, while error correction enables reconstruction or recovering of original data in many cases. Now, error detection means finding out a addition of noise or disturbance created in the communication data, and error correction means what to be done in order to receive the original data sent by the transmitter. Error detection is the detection of errors caused by noise or other impairments during transmission from transmitter to receiver, and error correction is the detection of errors and reconstruction of original data, that is error free data. Now, coming to the introduction part of error correction and detection, all error detection and correction schemes add some or other redundancy and some extra data to the message, which receivers can use to check consistency of the delivery message and to recover the data that has been determined to be correct. For example, I will give you a simple example. I'm trying to send a binary data called 1100 to you. Now, if any place of 0 or 1 are interchanged, or if any other additional bits are added in between, then we say that added extra bits are nothing but errors. And this is what he is explaining in a point, that in all error detection and correction schemes, they add some redundancy, some extra data, some extra bits to the message, which receivers can use to check consistency of delivered message. Now, I will inform the receiver prior that I am transferring this many bits of data. If error is added, if redundancy is added in between due to noise or disturbances created in the medium, what will happen? Receiver will receive the data which will be more than what I have told. For example, if I say I'm sending a 16-bit data and the receiver is receiving 20-bit data, that means there is a redundancy or error of 4 bits that has to be identified and it has to be corrected using any of the suitable code. Okay, now error detection and correction schemes can be either systematic or non-systematic. Now we will see what is systematic scheme, what is non-systematic scheme. In a systematic scheme, the transmitter sends the original data and attaches a fixed number of check bits. Check bits can also be called as parity bits or parity data, which are derived from data bits by some deterministic algorithm. If only error detection is required, a receiver can simply apply the same algorithm to the received data bits and compare its output with the received check bits. If the values do not match, error has been occurred at some point during the transmission. Once again, I will repeat. In a systematic scheme, what will happen? Transmitter sends the data. Along with the data, he attaches some fixed number of check bits. For example, as I told earlier, I am trying to send an 8-bit data. Along with the 8 bits, I will add 2 bits of checks or extra data. Or it can also be called as parity data, which is derived from data bits. Okay, if I'm sending the data bits, the additional check bits or parity data will also be in the form of bits only, which are derived from data bits by some algorithm. Every code has some algorithm. If only error detection is required, a receiver can simply apply the same algorithm. After receiving, he will know already that he has to receive 8 bits. If he is receiving more than 8 bits, he will only detect that there is an error and he has received 2 bits extra. Okay, if only error detection is required, receiver can simply apply the same algorithm to the received bits and compare its output. Now he has received 10 bits. Sorry, he has received 20 bits and the transmitter has sent only 16 bits. That means the remaining 4 bits of the data is error or noise. Okay, now he will compare his received data with what he has to be received. He has to receive 16 bits data, but already transmitter had added additional check bits of 4. So he will compare 16-bit data which has to be received and 20-bit data which he has received. Then he will know the difference. Now he will understand that he has received the data with 4 bits extra. The 4 bits extra is nothing but noise, or it can simply consider as parity bits. Okay. Now the next step is to correct the detection. Sorry, to correct the error. Okay, if the values do not match, error has occurred at some point during the transmission is saying. Now next point is, or next step to be taken is, he has to correct the data and send the original one. Okay, this is all about systematic scheme. Now, in a system that is using non-systematic code, what will happen? The original message is transformed into an encoded message carrying the same information and that has at least as many bits as the original message. Good error control performance requires the scheme to be selected based on the characteristics of communication channel. In non-systematic code, what will happen? Original data will be transformed, but order will be differed, order will be changed. For example, I will transmit 001111. He may receive it as 110011. The transmitter has sent the same data, same bit, 6 bits of data. Receiver will also receive same 6 bits of data, but the order in which the transmitter is sent will differ. In that case, that code is called non-systematic code. In systematic code, he will add extra bits which are referred as check bits or parity bits, so that the receiver will compare the actual output and what he has received. So in this case, it is easy to rectify whether there is an error or not. Error detection is easy in first case. Now in the second case, you are receiving as many bits as the transmitter is sending, but there is a difference in arrangement. Like if I send I like you, as an example. Now this fellow will receive I love you. That has a great change, but the number of bits what I'm sending is same. I hope you understand with this example better way. Now, now good error control performance requires the scheme to be selected based on the characteristics of the communication channel. Now, for this, I will tell you an example. Till now, we have considered some binary data. If I mix some binary data with some alphabet or ASCII character, that becomes a different case, because there are two types of informations in that. One is binary, which is accompanied by ASCII character. The receiver doesn't know whether it is an ASCII character, whether it is an alphabet, or whether it is a code. Okay, this is in the case of non-systematic code. Now, if the channel characteristics cannot be determined, or if they are highly variable, an error detection scheme may be combined with a system for transmissions of erroneous data. This is known as automatic repeat request. This is one type of error correction scheme. If in the previous paragraph, we have learned that it requires the scheme to be selected based on the characteristics of communication channel. Already in the previous video, I have told you what is a channel. Okay, now if the channel, if we cannot estimate or if we cannot determine the characteristics of a channel, what we can do, we can combine it with the system for transmissions for erroneous data. This technique is called as automatic repeat request and is most notably used in internet. An alternate approach for error control is hybrid automatic repeat request, that is HARQ, which is a combination of ARQ and error correction coding. Okay, these are the basic types, and this will be in case of two systems between computer 1 and computer 2. Now, error correction may generally realized in two different ways. One is automatic repeat request, one is forward error correction. ARQ and FEC may be combined such that minor errors are corrected without transmission. There is a spelling mistake, I think. Without transmission, and major errors are corrected through a request for retransmission. This is called hybrid automatic repeat request. Now, ARQ, automatic repeat request means it immediately corrects the data without retransmission. That is for minor errors. If there is a major error, then correction is done using request for retransmission. This technique is called hybrid automatic repeat request. These are the basic types. Now, error detection schemes. Error detection is almost commonly realized using a suitable hash function or a checksum algorithm. Okay, a hash function adds fixed length tag to a message, which enables receiver to verify the delivered message by recomputing the tag and comparing it with the one provided. This already we have discussed. There exists a vast variety of different hash functions designs. Example, CRC, your Manchester code, parity bit, checksum bit, Hamming code, Hamming distance, Walsh codes, NRZ codes, etc. Okay, there is one more concept called line synchronization. That is a different story. For time being, you remember only this. Now, error correcting codes are usually distinguished between convolutional codes and block codes. Now, whenever I have told about properties of Fourier transform, I told you about convolution, right? Convolution is one of the property. Now, error correcting codes are distinguished between convolutional codes and block codes itself. Convolutional codes are processed on bit by bit basis. Block codes are processed by block basis. Convolution is nothing but it will check bit by bit. Block is nothing but it will check byte by byte, because byte means 8 bits. In second case, 8 bits are processed together. In the first case, only 1 bit is processed at a time. That is the difference between convolutional codes and block codes. Now, next coming to what are the various error correction codes present for you. You have parity, checksum, cyclic code, line synchronization code, NRZ code, Walsh codes, and Manchester code. Almost I have given notes for every topic. One topic is left over, that is NRZ. I will try to complete by the end of this week. For today, refer error correction and detection, communication PPT, as well as yesterday's quadrature amplitude modulation and today's ADM, adaptive delta modulation. Remember one thing, next online test will be based on only these topics. I'm not going to repeat the questions from first unit. Make this point very clear, and those who are not trying to attempt online test, I am damn sure you're going to score very less in case of 8051. In case of a data communication, it will be a bounce. If you're not reading it, it will be a bounce. By hook or crook, you have to study each and every corner of data communication, because there is no chance of expecting any question from any unit for a particular mark. And you also already know about OU's decision. Immediately after April 20th, if he wants to continue with theory exams, you will be in trouble. And hardly if you work out only, you will pass in 8051. If you don't study, completely one anda, you will get one anda in data communication. Follow what I say and prepare for online test. Take each and every online test seriously, so that half of your theory preparation will be done.